So today we're going to talk about collisions between generally two objects. It certainly works with more than two, but let's talk about collisions between two objects. The first thing you need to understand is something called the law of conservation of momentum. It's one of those fundamental laws, kind of like Newton's laws and stuff, that applies everywhere all the time. And that is that the momentum of an object or of objects within a closed system does not change. So everything inside of a system, which we get to define, has a certain amount of momentum, and that momentum never changes. The total momentum is the same both before and after a collision. So two objects have individual momentum, they collide, maybe they bounce or they stick together, whatever, but there's now a new momentum, and the total of what we had before has to equal the total after. There are three types of collision, so leave room for three sets of equations and three sets of notes. The equations you can put on the left, maybe some pictures, and the notes on the right. The first of those is called recoil, or an explosion. Recoil, the classic example of recoil in physics is the firing of a cannon. So if I have a cannon and it's on wheels or skids or something, so it's free to move, and I have a cannonball and it's sitting still, it has zero momentum. And then I fire the cannonball. So the cannonball goes off in one direction, that's going to knock the cannon back in the other direction. And those two have to equal each other because the initial momentum was zero, so the final momentum must be zero as well. In truth, what really happens is the momentum of the cannon plus the momentum of the cannonball have to equal zero, which means one of them is negative. Okay? But I'm going to ignore the plus and minus in the case of recoil because it's easier to just say that P1 is equal to P2 and ignore the negative sign. Okay? That's easier mathematically to take care of. Okay? All right. So let's look at those equations. The momentum of object 1 is equal to the momentum of object 2. And you've already learned yesterday that the equation for momentum is mass times velocity. So we just label this m1 and v1, and that has to equal m2 and v2. So we consider these separate objects before and after when we do it this way. There are other ways. Now this applies also to an explosion. If I have a bomb and it blows up in every direction, its initial momentum is zero, which means all the individual momenta of all the individual pieces have to all add up to zero. But it gets much more complicated when I start looking at three dimensions. Because instead of saying I have a plus for this way and a minus for that way, and then in the case of recoil, I often just don't even bother and I just say they're the same. When I start looking at three dimensions, I have a whole lot of vectors and things like that, and it's very complicated. But it still holds true. Okay? It still holds true. We just don't have the math to do it in this class. The next type of collision is called an elastic collision. The classic example in physics is that of the billiard balls. So I'm playing pool, and I hit the cue ball, and it bounces off the 8-ball, and maybe the cue ball bounces back, or maybe it goes off in a different direction, or it stops. Various things like that. Now we're not going to be looking at momentum in multiple dimensions. We're going to be looking at it only a straight line, left and right. So we're going to assume everything occurs on a straight line when we do our math. But two objects collide, they bounce off of each other. That's where the term elastic collision comes from, because the two objects bounce. And we assume that there's no loss of kinetic energy in that bounce. Okay, because kinetic energy is separate from momentum. It's completely separate, completely different. In an elastic collision, there's no loss of kinetic energy, and under all circumstances, there's no loss of momentum. So if you're ever asked a question like that, you know, when do you lose kinetic energy, or when is kinetic energy conserved, or something like that. Those may be different answers. But when it comes to momentum, it's always conserved. Each object has its own momentum before and after the collision. So this is an elastic collision. Let's look at how we do that. So we have momentum of object 1 plus momentum of object 2 is equal to momentum of object 1 prime. That's what this little symbol here means. It's a single quote or a parenthesis, or an apostrophe in some cases because of typesetting. You know, it's a lot easier to hit that apostrophe button than to find that little symbol. But it's prime. So P1 prime plus P2 prime. And what prime really means is under the other set of circumstances. We could just as easily look at this and we could say P1 initial plus P2 initial is equal to P1 final plus P2 final. But that's what that little prime means. It just means we've got a set of conditions and we have the new set of conditions. So when you see that little mark up there, prime, that's what that means. New set of conditions. So when we look at the math for that, M1V1 plus M2V2, pretty straightforward, equals M1V1 prime plus M2V2 prime. In this case of an elastic collision, we assume that the masses do not change. It would not be an elastic collision if they transferred mass from one object to another. Okay, that would complicate things considerably. The last type of collision we're going to look at is called an inelastic collision. And the best example of this perfectly inelastic collision is when two objects collide and stick to each other. And there are two really classic examples of this in physics. The first one is that of the railroad car. So I have a railroad car here, and it has a little connector, and it collides with another railroad car that has a connector, and when they collide, they hook together and continue off as a single unit. Okay? The other classic example in physics for this is the bullet and the clay block. So I have a block here, or a wood block, and I shoot a little bullet at it, and it goes, and it sticks in the clay block and knocks the clay block or the wood block back. So the two objects have stuck together. When they collide, they stick. So how does that look like when we're doing the math? Because they each have separate momentum before they collide and shared momentum after. Well, it's pretty simple. So we have our initial momentum of object 1 and our initial momentum of object 2, and then we have this final momentum of object 1 and 2, or 1 plus 2. They are a single object now. Sometimes people even call that 3 for their combined. Mathematically, the left side of the equation looks the same as an elastic collision. We're looking at the momentum of each object. M1V1 is object 1, M2V2 is object 2. But what about the combined object? What's its momentum? Its momentum is the sum of the masses, M1 plus M2. So resolve this to a single number times the new velocity of the combined object, which we just call V prime, new velocity.